Hello, what I'm going to do in this video is walk you through how to use the law of sines and cosines. So I'll give you a brief overview. What I'm going to do is do a couple area problems that would require us to first use the law of sines and find a missing side or angle. So we'll do a couple of those, and then I'll do a pretty generic law of cosines problem, just substituting numbers into an equation. We'll solve a triangle, which means we're going to find all the missing angles in this case. The sides are given. We'll do another area problem using Hero's formula, and I'll also use the formula for area that uses sine to check our answer for that. So pretty short and sweet. So this first one, we're going to determine the area of this triangle. So what I'm going to need to do first in this in a kind of problem like this, when we're not using Hero's formula, is we're going to need to find basically in a triangle. Let me just label this A, B, and C. If A was my angle that was included between sides B and C, I could use the formula 1/2 of BC times the sine of angle A. So what you're really looking for to use that formula is an angle that is included between two known sides. So if that's the case here, in order to use my law of sines, I'm first going to need this kind of relationship where I have an angle and I know the side across from it. So what I'm going to be solving for actually is going to be this side over here first, and I'm going to call this x. And what we're going to do then to figure out what my x is, or actually, you know what, let me just use the traditional labeling. Since this is across from angle A, I'll just call this side A. So what I'm going to do for the law of sines is say I have the sine of 99 over 12. So that's basically saying the sine of angle B over little b, which is the side across from it, is equal to the sine of 43 degrees over the side across from that, which is A. And what we're going to do here is cross multiply. So I have A times the sine of 99 equals 12 times the sine of 43. And then to get A by itself here, I'm going to divide both sides by the sine of 99. And then I'll pull up a calculator and show you how this would look then. So A would essentially come out to whatever 12 sine 43 divided by sine 99 is. So I'm going to throw that in my calculator here, and first make sure my mode is in degrees. Alright, so then once you're on your home screen, you can press 12, and then sine 43. I'm just going to close that parentheses, and then put divided by sine 99. And that's going to give me my answer. So 8.29 would be this side length down here. So this is 8.29. I know that side B is 12. So if I want to use that area formula, I'm going to really quickly figure out what angle C is. I know that 43 plus 99 plus whatever the measure of angle C is has to be 180. Since since those are within the triangle here. So this is going to come out to 142 plus angle C equals 180. So the measure of angle C then is going to be 38 degrees. Alright, so I know that C is 38, so I can now use my area formula because again I have an included angle and the two sides around it. So A equals 1/2 of 12 times 8.29 times the sine of 38. And I'm going to throw that in my calculator, and I can just type in 0.5 for the half times 12 times 8.29 times the sine of 38. Just like that, and I'm getting an area of 30.62, and since it says meters, that would be square meters. So again, had to use the law of sines first. Can't use like Pythagorean theorem or just basic sine, cosine, tangent, because this is not a right triangle. In this next one, notice I'm only given one angle, so we're going to have to solve for another angle here in order to figure out what this side is going to end up being. So what I'm going to do first then, again, I have this relationship where I know this is 39. I can solve for the side that's across from my 41, which I'm going to be solving for angle R in this case. So I'm going to start off by saying I have sine 39 over the side that's across from it, which is 28. And I'm going to set that equal to, and I'm going to say sine R, whatever angle R is, over the side that's across from that, which is 41. So now that I have this information, I'm going to cross multiply and I have 28 times the sine of R equals 41 times the sine of 39. And I'm going to divide both sides by 28. So I'm solving for an angle here. So that's only going to change one thing really at the very end of this. So right now this is what we have. And I want to get r by itself. So since I'm solving for an angle that is within my sine function, I can't like divide by sine or something. So I'm going to use an inverse. So we call this arc sine. So all that you have to do differently in your calculator is just press second and then sine, and you can throw that information in. So I'm going to do this in mine. I'm going to press second sine, and in my calculator I have 41 times the sine of 39, closing a parentheses, divided by 28, and I'm getting an angle measure of 67.15 degrees. So that is what this is for angle R. And again, in order to find the area of this, I would need to have two known sides and the angle between them. So what I'm going to quickly do then is figure out what angle P is. So I can just take 180 minus 41 minus 67.15, and I'm going to get that angle P is 71.85 degrees. So again, now that I have my included angle between my two known sides, I can use my area formula, which says I'm going to do 1/2 times 41 times 28 times the sine of the angle between them, which is 71.85, and I'm getting an area of 545.44. And it looks like that is unitless, so whatever square units that would be then. So again, that's the law of sines. I'm going to kind of shift gears and go into the formula for law of cosines. Before I do that, let me show you when we would really use the law of cosines versus the law of sines, or when we really have to use that. So there's two cases. The first case, if I'm only giving you three sides, so let's say I give you sides A, B, and C, and you know what A, B, and C are. So actually, let me just make up some fake numbers here. If I said that this was 12, this was 10, and this was 14, and I wanted you to use the law of sines and figure out what angle A is. Well, I can't say sine A over 14 equals sine B over 12 or something like that, because now I have two unknowns here. So you cannot use the law of sines if you are only given three sides of a triangle. And then the other case is if I pretend that this is 42 degrees, and I call this 12, and I'm calling this 15, and I want you to figure out these other angles or sides. And I'm going to call this BC, and I'll call this a little a. I cannot say sine 42 over A equals sine B over 12 or something. Again, same situation. I'm going to end up with two unknown values if I try to set up the law of sines. So that's not going to work. So I'm going to bring in this thing that's called the law of cosines. And the law of cosines states that the side c squared equals a squared plus b squared, just like the Pythagorean theorem, minus 2 times ab times the cosine of the included angle between them, which is c. So I'm going to use this formula, and we're just going to substitute some numbers in using basically this. So this triangle, across from A I have 8, so 8 squared plus, and then my side B is 11 squared minus 2 times 8 times 11 times the cosine of the angle between them, which is 37. So I'll show you how to throw that in the calculator. And again, that is basically what c squared is. So what I'm going to do is type in 8 squared plus 11 squared, and then minus, and then this is where I'm going to open a parenthesis and say I have 2 times 8 times 11 times the cosine of the angle between them, which is 37. Throw a couple parentheses on there. Now that's what c squared is equal to. So I want to take the square root of that, so that is 44.44. And again, that's what c squared equals. So I just need to take the square root of that to get my answer. So I'm going to press second and then bring in my answer from before. So we're going to get 6.67. And that is what side C is. So now that I have that, if I were asking to find angles A and B, I would now be able to use my law of sines, because again, in the law of sines, you need that relationship where I have an angle and a known side that's opposite to that angle. So we wouldn't have to use the law of cosines again if I were solving this triangle. In this next one, this is the other case where we are going to have to use the law of sines, and to solve this triangle, what I'm going to do is first find the measure of one of these angles. I'm going to find the measure of angle C, And you're going to want to find the largest angle measure first, which would be opposite your longest side. So once we have angle C, I will be able to use the law of sines and figure out one of my other angles. And then from there, if I have two of my three angles, I know that I can find the third because they all sum to 180. So I'll start off by writing out that law of cosines again. So I would say 28 squared equals 15 squared plus 22 squared minus 2 times 15 times 22 times the cosine of the angle that's between those, which is C. So as far as my simplifying goes, I'm going to simplify the left, which is 784. And then I'm going to simplify this part right here, 15 squared plus 22 squared. I can put that in my calculator and get 709. And then I'm also going to do 2 times 15 times 22. And I'm just going to bring this whole thing down, basically. And that comes out to 660 times the cosine of C. So one of the mistakes that people just love to make with this is subtracting the 709 and 660, which would essentially be the same thing as me saying something like 6 minus 2x is 4x. And that's just a big no-no. Again, the 660 is being multiplied by the cosine of C. The 709 is not. So I cannot do that move. What I'm going to instead do is subtract 709 on both sides of my equal sign. And that I can do, and that's what you're going to want to do in this case. So I'm going to end up with 75 equals, and then be careful with your signs. This is negative 660 times the cosine of C. And my next move then would be to divide both sides by negative 660. And that's going to get rid of this. So now I really have that the cosine of C is going to be 75 over negative 660, which again, since I'm solving for an angle, I'm going to need to use an inverse function here. So inverse cosine of 75 over negative 660. So I'll throw that in my calculator. And I'm getting 96.54 degrees. So that is what angle C is equal to. Oops. And that is 96.54 degrees. So I have my first angle. And now again that I have this angle, I do not need to use the law of sine or law of cosines again. I can now use the law of sines. So how this is going to work is I have my angle and my opposite side to it. So I can say sine 96.54 over 28. And I'll just solve for angle B next. And I'll just say that is sine B over 22. And now this goes back to one of those first problems that we did. We're going to cross multiply and we're going to be solving for angle B. So we'll end up using inverse trig functions again. So I have 28 times the sine of B equals 22 times the sine of 96.54. And then I would do some algebra, blah, 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 blah. I would end up with B equals the inverse sine of 22 sine 96.54 over 28. And again, I can throw that in my calculator, press second and sine, and then 22 sine 96.54. I would close my parenthesis, put divided by 28, and then I'm getting that angle B is 51.32 degrees. So I'm going to now fill that in up here, 51.32. And then lastly, again, if I want to figure out what angle A is over here, I know that these three are going to sum to 180. So I can take my 51.32 plus 96.54. 51.32 plus 96.54, and that is 147.86 for those two angles, and I'm going to take 180 minus that, and I know now that angle A is 32.14 degrees. So again, basically you had to use the law of cosines first and figure out my largest angle, and then from there you can use your law of sines. And then lastly, I'm going to go through this thing that's called Hero's formula. First part of Hero's formula is we have this letter S that we use to represent what is called a semi-perimeter, which is 1/2 of your perimeter basically. So it's like how you have a semicircle is half a circle, semi-perimeter will be half the perimeter. And basically then your area is going to come out to the square root of S, and then I'm going to make 3 parentheses inside here. So you take this semi-perimeter, and then what you do is you take the semi-perimeter minus each of your side lengths. And it looks like it'd be a really complex formula, but it makes life a lot easier than having to use that law of cosines again and figure out an angle and then use our sine formula, and I'm going to show you both. So if we remember from before, angle C was 96.54 degrees. I'm going to use this to check my answer later. So again, I'm going to do this problem two different ways. I'm going to do the one on the left with the hero's formula, and I'll let you be the judge of which way is easier. So the first thing I'm going to do is figure out my semi-perimeter. So I'm going to take 1/2 of 15 plus 22 plus 28. And if you're going to the calculator on this, just be careful with parentheses. If you type in the 0.5 times 15 and then add the other two, it's not going to do the correct order of operations. So you're going to want to add and figure out that your perimeter is 65 first and then multiply by your half. So my semi-perimeter is 32.5. So now I'm just going to kind of build this formula. I'm going to say my area is going to equal, and I'm going to bring my 32.5 here, and I'm going to open three parentheses. And I'm going to fill these parentheses by taking 32.5 minus each of my side lengths. So I'll do 32.5 minus 15, and that's going to give me 17.5. And then I'll do 32.5 minus 28, which is going to be 4.5. And then I'll do 32.5 minus 22, and that is going to give me 10.5. So now you can just throw this whole thing in your calculator. My area is going to equal the square root of that whole thing. So I'm going to press square root of my calculator, type in 32.5 times 17.5 times 4.5 times 10.5, and I'm going to get a square root, and then that is 163.93 for my area. So again, that is just one way of figuring out my area. The other way with this problem, again, if you were only given three sides, if you wanted to use the law of cosines and figure out what this angle is first, you can, and then you would use that formula that we used before, where I said A equals 1/2, and we took the two sides that were around the included angle and multiplied them together times the sine of that angle, and you'd get the same answer. So I'll pull up the calculator and hopefully I'm going to get the same answer. That would really suck if I didn't. Alright, so I'm going to go in the calculator, type in 0.5 times 22 times 15 times the sine of 96.54. And if anything, it'd just be a little bit off just because of the rounding, but this should be the same answer then. So 163.93. And again, it is the same answer that we had before. So two different ways of doing the same problem. Again, the one on the right looks like less work now, but that's because, again, we already solved for angle C by using the law of cosines, which is what we did in this last problem, basically on this whole left side here. So I think Hero's formula would probably be a little bit less work, but again, that is entirely up to you. So again, law of sines and cosines, basically things that you can use when we do not have right triangles.